Hi guys, good afternoon. Welcome to the Manufacturing Innovation Virtual Workshop Series. I hope you can all see and hear me okay. So as most of you know, we are kicking off the series this afternoon with Jesper Tubel from the Lego Group. Jesper is the VP of Elements and Molds. He's going to be giving us some insight into the drivers for Lego to engage in new ways of working, particular attention given to new opportunities for manufacturing and engineering and some digitization techniques. The session, will consist of two parts. The initial presentation, I think Jesper has some visuals and some videos for us. We have around 60 minutes, so after the presentation, we can engage in some Q&A. I'm sure some of you will probably have some questions, and Jesper will obviously do his best to answer them. So Jesper, welcome on board, and over to you.
Thank you, Daniel, and thanks for everyone that wanted to listen to me here on where I'm sitting. It's already dark in a warm January. So what I'm going to talk to you today is actually a part of a journey we are on as a company on working on digitalization, and it's not this is not at all everything Legos is doing. But this is something I work with where my part of the organization. Just so you know, I'll explain a little bit what we have been working on. Also, place you so you know where you can navigate in the Lego organization. So know what I'll be doing, and I'll be more in that presentation. I understand from Daniel that we will park the questions until we're done. Of course, if there's something you don't understand, Daniel, I'm sure people are allowed to just send them comments to you or whatever, so you allow
absolutely. Yeah, sure. There's like a chat room people will see at the bottom of their screen where they can type and ask questions. So if anybody does feel the need to interrupt or have any questions about anything specific, just type them in there. You should be able to see them as well, Jesper, and then you can answer as you go. But if we can, obviously we'll try and wait until the end for the questions and do them all in one go.
Super.
Cool.
I'll just continue here just to a little bit, so you know what Lego is about. I brought a small video explaining our product because I assume you know it, but I think sometimes it's good being reminding on what is this really about, and that comes now.
Race cars, a boy's dream, a man's reality. Building the perfect race car is an art. It takes skill, dedication, patience, and passion. It's the kind of passion that turns men into boys, and boys into men. Lego, Porsche, we build race cars.
So of course, I hope that left a small smile in your, that this is actually what it's very much about for us. We are, as you know, a really humble and a proud producer of something from the most important in many of our life, and that is our kids. And that's what we have our 80 years of history have been doing. A little bit more about the Lego Group, and that's just some factual thing. And I know that's not really, you don't look for large company presentations, so I'll not do that. But there are some of the things that have a logic to why I actually worked on digitalization, and that's why I thought it would be a good idea to show that to you. This is from 2016. Lego is, Danish. Very proud of being Danish in the darker corner of Europe. We have a revenue in 2016 around 38 billion Danish kroner, and that equals to around a little more 4.2 billion euros. We had a great operating margin. You can reach that yourself. And in the end of 2016, we had around 19,000 employees. We have been lucky to, at that time, had 12 years on consecutive growth. and we actually are super proud of selling our products in more than 140 countries around the world. What makes it a little bit important from a digitalization point of view is that we actually release or sell 60% on newness, on new products every year. So, you know, our portfolio has 60% of new products being sold every year. Lego have also made some critical, tough planet promises, at least what we think ourselves. We are, you know, a high quality product, so that means a very strong quality, no product recalls. We have a strong partnership with some of the UN organizations, and also engaged in a lot of social local community activities. Low injury rate with our staff, and then something very important from a digitalization agenda is actually our energy efficiency, where we've also looked into and are still looking how can we be more efficient when we do molding, because molding is of course a power consumption technology, and that's where energy efficiency from a planet point of view is always important. Then our recycle our waste, that's also very important for us, so we can work on not giving anything back to the planet that we do not really wish for. And then we also work very much with renewable energy, and very much also with our owners investing in wind turbines. So you can actually see that on the next slide. And I'm not spending so much time on this, but you know, that's a positive impact. Lego want to make this explain a little bit the same thing here. One of the things that's not mentioned is also the what we call the Green Box initiative, where we actually went one packaging size down, you could say, from all our packaging, you know, the Lego box you buy, and we actually made all our different sets in a box that's smaller, so not making bigger, but and then we of course 100% FSC certified. If you know anything of this presentation, you should really remember that's I have listed some fun facts here, 4 of them, and that's actually just that if you looked at in every person in the world, each person in the world will own around 102 Lego bricks. Over the years, we have produced more than 760 billion Lego elements, and in 2014, we actually produced one every 60, we produced 60 million bricks, and that's 1,900 bricks each second. And then our famous minifigure is not really shown here by the kid. That's a classical, what we will call a 2x4 brick, but the minifigure that many kids see as an avatar for their play, that's the biggest population around the world if you just take that in count. So we do a lot of minifigures. That's just our core thing. I'm sure you know many of them and been hopefully playing with them as well. And that's where I'm in the organization. I'm part of an organization unit called Elements and Molds, and it's pretty simple. That's actually what I do. All the technical specification of a Lego brick, we call them elements internally in Lego, and that's what I do. So everything on the plastic, my plastic engineers design and specify, so we know exactly that the element get the quality for our building system as we want. And then I also have the pleasure to make all the molds, the injection molds that we use. We are heavily injection molding company. And then we also run in the molds. That's a big part of our business, to make sure that we know how the molds should run in production, and actually also ramp up the molds in what we do. So that's a big part of my organization here. It's also explained a little bit here. So maturing design and specification of the element, finding out the quality, doing a lot of measuring on you can see there's a small picture of a size machine, and we produce you see in the right corner the injection molds of steel, and then also a lot of new technology is developed in my area, of course, because if you think the variety of the Lego bricks in both size and material types and everything, then it actually requires some development all the time to be able to do the new Lego bricks that we develop every year. What I have, jumping into what I have discussed, I want to discuss with you today, share today, that's actually some of the manufacturing digitalization we have done around making molds and elements. And there I'm going to show you a little bit in the beginning broadly and then also, you know, more concrete, some example of how we have brought this to to the level we are at today and still working on. When we started all this, we actually started, I think, like many other companies, just to navigate in an ever-growing, you know, information level around Industry 4.0 and digitalization. And what we started to do is actually to see, you know, what manufacturing trends are there, what could that do to enable our future manufacturing competitiveness. And that's, we looked, as you can see in the left, also, we stole the pictures from here, or copied with pride from Wikipedia. What is the fourth industrial generation actually doing of connecting, you know, all your production equipment and all the process of the product you make, so you really know much more of what you're doing. I love this. You can already probably sense that I'm talking to big data, and that will be one of the really key things for where I am and what I work with. We also know that it was exponential development, so you know, what we knew 3 months ago probably is some kind of not, you know, not really outdated, but at least a knowledge we need to constantly stay ahead on, because it's one of the most fast-growing in exponential technologies. We actually gave some from our top management some concrete example of what is it. It's actually, you know, you can see it here, programmable manufacturing machines. We use, of course, a lot of CNC machine and additive manufacturing of metal, and it's also much more robotics. There's something tool for planning and managing our factories, and then there's much more on the connected devices I've already spoke to. So that's the way, just to know, you know, you've probably seen many definitions, but this is the way we have defined, and that's the way we work with it. So it's probably also what is it not, you can see out of this definition for us. We translate that into some external trends and drivers that could, you know, into our opportunities, and we basically group that in two things. So Industry 4.0 to our digitalization in production, and then 3D printing into additive manufacturing. On the left side, you can see some screen things of what we have been doing. So basically, the first picture show, you know, how we did decide our production. We made some the drawing machine, or the drawing, you can see there's a molding machine. There's some factories in the middle on the globe that are connected, and then there's a lot of other equipment that could be connected in production. Then we did a lot of additive manufacturing. One thing for product. So is there an opportunity to do Lego bricks that we do not currently can do in injection molding? And it's also an opportunity for really additive manufacturing of, also called SLS, to be applied in our production. So simply use metal parts to 3D print things where, you know, injection molding is very much about cooling and getting the right cooling channels. So there's sometimes, or actually a lot of times, you cannot really drill what you want to do and out in your CNC machine, and that's where it gives an opportunity to use a 3D print to really get the shapes and you want. Digging into more digitalization and production, we actually tried to map what will that mean for us. So you can see on the left side, there's again the same Industry 4.0 definition, and then you can see what have we defined we want to work with. And just to read it for you, then we looked at additive manufacturing, augmented reality, big data analysis, autonomous robots, simulation, and also you know, connecting things in the industrial Internet of Things. So that meant that we, you know, it's on the left side, that is the 4 things we choose to work with. There was a lot about our user simplicity, so let our operators having much more access, easier access to you know, menus on the machines. The big data analysis I already talked to, so really start collecting data in our process to optimize the process. The smart factory have we discussed a lot and also tested things on. And then very, very important, what I'll talk to more today is actually the sensors, because that's some of the things we see in the process we work with as a sensor technology being something we could apply more and more to learn more about our process, but also really to optimize when we actually produce our Lego bricks. We have worked with in the production. There's a lot of outcomes, and that's why I'm doing it shortly now here, because I will go much more into to the area that I've been working on. But you know, you can see here in the pictures, there's been a lot on testing various things, and we have done a way where we've done small prototypes. We call them demonstrators, so we could actually show from our different stakeholders and our top management what this could be used for, instead of doing you know, big 3-year projects. That, as an example, we've done stuff that is pretty fast, 6 weeks, so we get a maybe 80% solution and then show it really in a Lego context what the value will be of what we are doing. So that was a lot about the process, and then we have looked into also the printing and done on plastic printing, doing various parts on how this will look like for us. So is there an opportunities to simply do total new products using 3D printing? And we have tested a lot on that. Also did in some of our brand stores. You know, Lego have our own brand stores. At least I know there's one in London on Leicester Square, where we have done various example where, you know, a customization of Lego bricks done. You can see this example here on the picture where we did in our New York store, also tested out on the Flatiron, in the Flatiron store, how we, one of the 2 New York stores we have, I think, where we did this. And then what I know much more about is actually the additive manufacturing in production, where we have done much more on, you know, doing parts for metal that you can use for both low volume production, but also increased flexibility and responsiveness on parts, and then the whole capabilities of these metal parts that can do much more. It actually come more on this one. You can see example of things we have done. We have done both in our processing, but definitely also in our metal parts. So there's example here of where we do different designs. One more slide here on you know, a lot of learnings how we have done it with our engineering teams. So have this an opportunity to do a lot of small scale production, and as an add-on to our mass production, because there's no doubt Lego is a mass production company. So is there opportunity here to work much more closer to doing small scale. Then you know, has this could be able to give us new competences and a competitive advantage. Here's some of the learnings we have showed by our first part of it, digitalization of production. So could it be the next level of capability building, really to understand our core capability? How could that be increased and multiplied? We also saw how can a data-driven approach giving us much more insights to things that we did not have insights to previously. With the onboarding we have gone through and opening new production sites globally, could we not, you know, this is a massive load on the organization when we do that, could we do much more easier training? Could we manage the complexity in our production much more with machines and not people? That's also something we have looked into. And then, you know, higher quality output, and we'll reduce the resources that goes into to what when we produce, so less using less waste, for example. And then something that's becoming more and more important for us is also having a traceability and reliability in our product. It's kind of always been there, but it's also increased what we could do. In the additive manufacturing for our products, I've already spoken a little bit to that. You know, could that add on the innovation, so a new product newness, things that we have never seen before? Could it reduce our lead time as well, bringing our elements faster to the market? I've already talked to the small scale, high quality manufacturing. Could that complement our injection molding capability? And also, you know, we need to have an understanding of design for additive manufacturing, because that's a complete new way of thinking for us as well. And also, you know, the functional materials, because many of our plastic elements today, they have both, you know, a design, but they also have a function, as we call it, because they need to be built together into a building system. So it's not only, you know, making something very, very cool that can stand alone. It has to fit into a building system of you know, many ways a kid and a designer can use the bricks. So that's also a thing that where I think we are pretty advanced of connecting plastic in the way we do the whole system, and that's putting a lot of technical requirement to the materials. And then, as I said, on the additive manufacturing, both plastic parts, but also metal parts, that's, you can read it here yourself, but that's a lot about agility and flexibility. I spoke to that. Reducing our lead time, always for any, and if you probably can nod to that, reduce our costs. Could also empower our employees to solve problems much more locally, and you don't need these central teams to do it. And again, also for, when we work with our IP partners, so that could be business of the world, could we do much more fast prototyping and small volume for tests. So that's one of the thoughts we have done. That was kind of the very, very broad introduction to where we in our operations part have been working with digitalization and IoT. So now I'll dig much more into my own area, where we have taken an approach to see how we can make the mold making much more digitalized. So you could say that the example I will give you here, we will come into, is actually investigate the prospects of a real-time adjustment of the production process to really minimize the production downtime and material waste. And that's a lean thinking in the way we do with our production of molds and optimizing molds. We actually looked at, so this is, as I showed you in the beginning, a very simple drawing of a molding machine. So you can see the screw, that's the vertical look like a hammer. If you don't know so much about it, or it looked more like a pencil, maybe that's probably the right word. That's what's below the triangle you see where you add the material, and then you have the mold symbolized by the black square where you can see the hammer inside. And then we put this, like a doctor's way of thinking, because we actually want to know what happens inside the molding process. We also had an idea on being able to measure the bricks, because as I told you, an increased wish for traceability and understanding the quality. So could we build a system where you could know everything about every brick we produce, and also really measure the manufacturing process. As I told you, that the heartbeat on the process, so we know that when we put up a mold in a mold machine, that's actually running according to our specification, and we do not need to touch it. And we don't want our operators to measure what we produce and then adjust. So simply have the machine being self-adjustable, and that's what I'm going to talk to right now. We did different demonstrators here. As I remember, I told you in the beginning that we had some what we call demonstrators, things that we wanted to do. So one of our first ideas was to really, could we use the very steep newness of technology to make an image of the tools. So the tools we are using the modern camera and 3D visions of the shape, to instead of traditional measure, could we then 3D scan all our bricks and then know where they're in the perfect shape. That's one of the ideas we had. We also wanted to still weigh the bricks, but the bricks to put a weight on them. But could there be new ways of doing, instead of a traditional way of them running on a conveyor and then weigh them? Are there other way of doing that much more smartly with digitalization? One thing, that maybe sound pretty simple to many of you, but do we have, are we fully in control of the molds? We have many molds in Lego, so are we fully control on the condition of the molds? And so we get the best product, and then of course we will like to do that much more smart with using smart codes. Probably sounds a little bit simple, but it was actually a big thing for us on our tool inspection. And then one of my favorites, could we really set up, like if you go into production, you can often ask a very senior operator, how is things running, by just listening and almost have the vibration of the machine, like listening to the machine and touch the machine with your hand and then know if this is okay. Could we build that kind of experience into sensors, so we could get proactive if machine starts to being not producing the right way, then react before machine breakdown, and do it a whole different type of maintenance on the machine. So put much more intelligence into that. And then a lot to the material properties. So, you know, is there a lot to the moisture when you do injection molding? There's different material that react to moisture. I know some of you that are on the call, you know everything around that. There could be the density and also the viscosity that could change the material, and we need to adjust accordingly. And that could be something we really should run, so we do not generate material waste and actually not missing a production order. And then last but also least, you know, it's not only the molding process, but also mold should be calibrated to the environment it's in. You know, we produce in many different parts of the world, and we use the same material. So having machine and environment adjust to the process or to the region we're in. So you know, is it a region with high humidity, very hot temperatures, compared to, you know, where I'm from, where it's, you know, normally very cold, or not very cold, but colder than, for example, Mexico. Could that also be a fantastic thing to work on? Yes, and then we would also like this heartbeat monitor to measure the process, so we get constantly tracking of the process. You know, when we mold, could we then know exactly what condition that every production batch were running under, so we are in control of our product and generate all these data. And then also, you know, not at least when we introduce a new mold to the manufacturing, could we automatically calibrate the mold, what we call the mold card, so how to run the mold. So that could also be interesting in both, also a lot of external equipment days around the mold. There could be, I'll become a little bit more technical, but regrinding of our inlets. It could be, you know, the drying of our materials and stuff like that. Could that be done so we connect all the different parts? So that's been the thinking from the beginning. Then I'm deep diving on one specifically, and that's something we call independent process control. So could we have, you know, just let the machine, if there is a variance, for example, from one batch to another, let the machines calibrate based on the baseline there is in the machine. And now it becomes a little bit more molding nerdy, but if I hope really you can follow me on this topic. We call that independent process control, and that was really to make the machine and the process independent of materials, machines, and production side. So we would like to measure directly where the element is produced, so that's called the cavity in the mold. And then we like a sensor to really measure, is this the right condition we are producing under, measuring both the pressure and the temperature. So the machine could do a closed loop control to self-adjust and make the bricks come back to the, you know, the baseline. We have defined the optimal line of the production. So it's very, very simple here. I show, you know, going from a constant process on the mold to a much more constant process in the cavity, so we know exactly what happens in the moment our product or our Lego brick is made in the mold. And just very, very simple, injection molding is, everything is about time, the speed you press the material into the mold, and also of course the temperature. So we have the right melt temperature of our material, and of course the pressure you press in with, because that should be where, you know, things can really adjust and being working according to our specifications. I will actually go through this very, very fast, but actually showing what the method we are running on when we do injection molding as a phase here, where we inject the material into the mold, and then there's where we keep the pressure, so we make sure that every material gets to every part of the mold, and then we cool down the material, so we get the element we want. And if you, of course, you can see, and if you know anything about the injection molding, then the cycle time is a super important cost driver, and also for, you know, how efficient can you run your production. Here it's really what I want to show you. So on the side here, on the corner of on the right corner, you see a brick where we actually have made a baseline. That's where you see under a condition where we run in. It's not really important you understand the axes, but you can see there's some numbers that's defining our baseline, and that's where the optimal for this brick and this material is to produce this product. And then we actually change the batch of the material and doing really crazy stuff where you can see some of all the different dots got out of our baseline, so they're simply outside the norm, both lower outside the norm and actually are also above the baseline. And then we let the machine do self-adjusting, so only by sensors and adjusting the pressure and the temperature. And then the machine actually self-calibrated just by knowing and not on measuring on the product after they've been molding, but in the process reacted to what happened with the sensors in the mold, and it self-adjusted. And that was kind of a really big opening eyes for us, that you can actually use standard products and then make machines close loop them if something happens. That's a fantastic thing for us when we develop and test new things into our molds. We have not yet introduced this to production, and we don't know yet if we want to do that, but it's definitely a huge part of when we develop a mold and run in the molds to understand if they deliver the product we want. And that's why we call this the new cash cow, because could we start, exploiting and taking test time out of our molds and running in of the molds in a whole new way. So we reduce our lead time and actually also our investment in the molds. I think that was kind of where I wanted to go, and I do not really hope I spoke too fast in the end of the day here. I can see we have just used 35 minutes. I think, Daniel, we will be ready for the questions right now.
Perfect. Thank you very much, Jesper. Very thought-provoking content, as always. So, yeah, the participants on the call, you should have at the bottom of your screen, those of you that are watching in, there should be a Q&A box and a chat box where you can type questions, and hopefully Jesper will have the answers. So if anyone has any questions, please feel free to type away, and Jesper will follow up. Okay.
Yes.
Okay, so can you see the questions come up, Jesper?
Yes, I saw one from I think yeah, there's one here.
Okay, cool. David. So yeah, I'll let you lead.
Yeah. So thanks, David, for your question here. So I'll just read the question in case not everyone can read it. How many plants are in operation? How do you leverage the best practice across the plants? So currently we are considering to as running in our molds to install this in 3 locations, maybe 4 locations, and we also make sure it's very centralized. So yes, the local teams are involved, but it's very much driven from a central point of view from the beginning. So we have not got into a maturity where where it's best practice has been shared, but normally when we do work, then there has been no issues on the size sharing because we run very much standardized. So it's the same materials we use, it's the same molds, it's the same molding machines. So we normally get the best practice very, very easily in Lego in the way we run. I hope that answered the question, or then please just retype. Then there is a question here from, I hope I pronounced your name correctly, Khalil Demelio Lessie. I'm probably wrong, but
that was a good effort.
Yeah, it's probably the same for pronouncing my name. So how was the organizational change? That was the question in terms of skills and capability. Did you have to hire some new type of profiles? That question's been off when I've talked to this part. We very much used a lot of our experienced guys, but we also hired new people that come with a much more digital background. And I think that's been one of my key learnings for this, that we have functional experts that really understand the physical injection molding we are using, but we also hired a people that comes with a much more, you know, digital electronic background of engineers and technicians that could support. So this is the great thing I see around using IoT, is that it actually opens up for a combination of more, you know, mechanical, I think you would call them traditional engineering disciplines, and then you combine that with some of the new guys that are, you know, young, and that's not because there's a generation thing here, but I think there's a millennium thing that comes in and challenges us, and I think that has been fantastic. So some of the new guys, they have a can-do attitude and connecting things in a new way, and that's been also fun in that, because you know, many of these guys, they're used to just pop things on social media and ask their network on how can you solve that, and we actually need to teach them that in many of the business, it's a little bit more confidential what you do, and there's a lot of you know, everything cannot be done by freeware. You need to buy licenses and everything. So that's been pretty a learning to get these new millenniums on board. Hope that answered. Then there is a new question here from Frederick Maurice, you know, this question is, hi, what sensors and IT system are you using to collect data on the machines? The sensors we are using is standard sensors you normally will find in automotive for, you know, diesel engines. So that is standards off-the-shelf sensors that, while we have been buying them, they have been, you know, completely also dropping in price. I think they at least 60%. We are lucky that we went to see what automotive use, because they have the volume, and that's also why we use them. And some of the IT system beyond that's been very much homegrown, some of them, but also looking into a system that's called Authentic. That's actually a Swiss system that we have been using. Yes, I hope that also answered. If not, then please just follow up.
Jesper, there is a couple of questions in the Q&A part. I'm not sure if you can you see that on your screen at the bottom?
It's Q&A. Yep.
Yeah. Okay. So there's a couple there that they're relatively new ones.
Yes, I can also see that's a good question. Yeah, I love the first one from Jakub. It's called, do you also use a mesh system to orchestrate all the production line, or are you in the process of implementing it? It's a fantastic good question. We are in the process of looking into an overall broader mesh system for the company, and have been for some years. You know, the traditional companies you know, a lot of people claim that have that, but the mesh system. But we're also looking into what should be that. Maybe it's not one system, maybe it's much more of a platform. And then our idea is maybe that we should not use, like you traditionally would have done on some of your you know, legacy system like SAP and stuff, using many years to get that implemented. On mesh systems, we probably see that you use much more an API approach. So using smart devices and get a layer between the mesh system and your smart devices, so you get information presented in a much more user-friendly environment. So that's one of the things we've looked into. And then Kevin asked a question here that says, for independent process control, how long does it take to set this up? Any challenge in achieving payback for this sort of investment? You know, for us, running in molds, that can add a lot of cost to running in a mold, because it's man hours and machine hours you need to use to get exactly that quality you want. So I think we have seen on those molds where we have implemented where we got issues, that has been a fast payback on the molds. It's much more the thinking time than actually equipment time. As I showed you on the slide, it's very much traditional things we are using. So I think the production or the payback time has been pretty fast on that one. Yeah. Okay, cool. Any more questions? Okay, I think you have a new one, or we answered that one. Let me see. I just from Frederick. I think I answered that one. Oh, you've already answered that one. Yeah. Yes. Oh, there's one more. Sorry, there was a follow-up. Okay, cool. Have you got a paperless factory? That was I didn't see that question. I thought that might have been a new one. Yeah. Yeah, that was also a new one. I think that. No, Lego is not completely paperless. As I told you, you are in the engineering part we're trying to be very paperless when we do our new molds. But when we get into production, we are not paperless yet. We are working on that, especially on quality report and audits and stuff like that to make that more digital. But we are not completely paperless. And then there's one more from David here that says, you mentioned there's a top-down cascade of ideas. How far down the above market concept of management are you? And do you feel most important concepts are generated in center or locally? Also a super question here. We actually discussing all the time how we get this to the senior management attention. I think we just have got a new, top management. There is a lot of appetite for digitalization, and I think we will improve the way and the focus on getting things implemented. We were also discussing right now if it should be more centralized or locally, and I think we will probably do a combination. So we also mobilize our production sites in much more on getting local presence. Then there is an anonymous attendee here that's asking, to what extent is the production linked to maintenance and supply chain? Can the molds order their own spare parts and materials? I think that's a fantastic idea. That should absolutely be one of the next things that molds should, when we know if, how long time, we know exactly on the machines how many shots and they have been running. So that should be clearly integrated to if we also can have the heartbeat seen if we should do that. It's not there today, but it's a fantastic thing of doing, and I think it's a great idea. I'll actually hope I can borrow that one. One more question is, how far are you from personal brick production? So can I print my own bricks in my shop or house? We are far from that. As I told you that we are still looking into this, and also as I told you, some of our brand shops, we call them Lego shops, not very intelligent name in Norway. That's what I call. There is an opportunity. We have a piloting. We've done one in Shanghai and one in Houston, and I think also in New York. I think we are planning also in London to do additional to the brick, so you can do that personalization of our Lego bricks, but not a full set. I think they will take years. That's my personal opinion, to be able to print a full set. And of course, there's also the whole material guarantee and the quality if we made this done by the consumer themselves. Then Anne asked a question here saying, have you noticeably been able to reduce error rate failure in production by the process control of molding machines? And that's also what we're working on. That's one of the ideas we want to do that. So that is really to make sure that that when we have a high quality today, so that actually we're able to see, could we maintain the same quality by much more automatic and digital instead of a manual process where we have operators to control. So I think I would say yes to that. We can, our testing is showing that we can keep doing that, having a very high low error rate. Then there is one here from Kevin, that Denmark already has a reputation for being one of the most advanced digital economy globally. Do you find any cultural challenge as you take this to plants globally? How do you overcome these challenges, and if they exist? Thanks for that. It's also a relevant question. I think at least what we see in Denmark, that is completely correct. It don't seems like being a resistance around our employees. We are in the process of rolling it out to another European country, in Hungary, and also Mexico. And I look forward to see both the skills level of our staff there, but also the resistance. So far, Lego employees in general very creative. So I share the concern here that it could be a capability thing they need to build up, but also an openness to and trust to a new way of working. Great.
Okay, yeah. Any more questions, guys? We have approximately 10 more minutes left on the session. If anybody has anything else to ask Jesper. Okay. Doesn't seem like there's any more questions to be asked. Anything else from yourself, Jesper?
No, it was really thanks for the many great questions. That I enjoy that, because that's what make not this. It's a little bit then you get a dialogue as the best way we can with this technology. So I just want to say thanks for people for listening in, and also giving me the chance to reply on some questions. So thanks a lot, guys.
And thank you to you, Jesper, and thank you for everybody for tuning in this afternoon. After the session, if anyone has any questions for me personally, just drop me an email and let me know, or any more questions for Jesper, and I'll try my best to relay them and get some answers for you. But apart from that, I wish you all a very pleasant evening. Thank you again, Jesper, for your ongoing support, and I wish you all the best.
Welcome, and have a great day or evening to everyone.
Cheers.
Cheers.
Goodbye. Thank you very much. Bye-bye.
Bye.